Blue shift or hypsochromic shift of UV visible spectroscopy, that's what we are going to discuss in this very short video. Say we have a molecule which is absorbing at a longer wavelength, and due to certain reasons which we are going to discuss later on, its lambda max or the peak of maximum absorption shifts from a longer wavelength towards a shorter wavelength. This is called hypsochromic effect, and the shift in wavelength is called as hypsochromic shift, or it is also referred to as blue shift because moves towards the blue end of the spectrum. If we speak of visible spectrum, the red end is at the higher wavelength end and the blue end is at the shorter wavelength end. Why these blue shifts occur? Let's say we have a molecule of like aniline benzene aromatic system with NH2 group where nitrogen has a lone pair of electrons, and it absorbs at 280 nanometer. And if the pH of the system, or due to certain reasons it is protonated, the lambda max is shifted from 280 nanometer to 203 nanometer. That is a shift due to the unavailability of the extended conjugation due to the unavailability of the lone pair present on the nitrogen atom. It can also be possible due to a change in the polarity of the solvent which is being used for that analyte. Say for example, we have acetone here, which has pi electrons as well as it has n electrons. So there are possibilities of pi to pi star transitions and n to pi star transitions as well. If we focus on n to pi star transitions in various solvents, starting with say chloroform, which is relatively less polar, the lambda max is 277 nanometer. Using ethanol, which is more polar, the lambda max is 272 nanometers. With methanol, it is 270, and with water, which is highly polar, it is 264.5 nanometer. Apparently, we can see a shift in lambda max from 277 towards 72, 70, and 264.5 as the polarity of the solvent is enhanced. What do these polar solvents do with the molecule or with the n to pi star transitions? Actually, with the n electrons of the acetone here, the water can make relatively more stable hydrogen bonds in its ground state rather than in its excited state. So that's why it becomes difficult, and it will require more energy to excite these electrons or to do n to pi star transitions, and therefore the lambda max is at towards the shorter wavelength. So there may be the effect of solvent, or it may be the cut down or removal of the conjugation from the molecule that can make its lambda max to shift from longer wavelengths towards the shorter wavelength, and overall this effect is referred to as blue shift or hypsochromic shift.